Okay, greetings. I'm Dr. K. Raghuram Mohan Reddy. The course name is Unconventional Machining Process. Today's topic is parameters affecting the quality of laser drill holes part 3. Associate Professor, Department of Mechanical Engineering, Institute of Aeronautical Engineering. Okay, at the end of this session, student will be able to understand parameters affecting the quality of holes. So this is the course learning outcome of the today's topic. Now let us go with laser beam machining directly. Okay. So under this we are covering the quality of drill hole. Okay. Right. So these are the laser drilling capabilities. Okay. Already we have seen in our previous presentations. Okay. However, just refer at a glance: diameter, depth, angle, taper, depth to diameter ratio, drilling depth, tolerances, and minimum corner radius. So these are the values corresponding to hole features. Okay, right. Now let us see the parameters which are affecting the quality of holes. Working material, environment, laser pulse, focusing lens, assist gas. So, however, the listeners or participants or those who are watching this video try to understand in part 2 and part 1 this process chart has been discussed already, but this is the extension for the first two presentations. Okay, right. Applications: drilling, plating, heat treatment, cladding, alloying, welding, and machining. Okay, right. Okay, up to here we have discussed in first two presentations. Now the next parameters which are affecting the quality of drilled holes. Okay, right. Texturing and structuring. Textured steel and aluminum strips or sheets are widely used, particularly among car manufacturers. Okay. Next, texturing facilitates lubrication during metal forming and prevents adherence of sheets during annealing. Usually during uh, metal processing or some other annealing operations, usually the sheets will come in contact and permanently trying to stick each other. That is nothing but adherence of sheets. Okay. Next, the process is applied to the roll from which the steel or aluminum sheets takes its surface pattern during the final stages of cold rolling. Okay, right. So this is about texturing and structuring. Okay, right. Laser beam machining has replaced the conventional SB method. Accordingly, the product designers can accurately specify the texture, putting in mind that the hardness of the roll is not a limitation. In laser beam texturing, a beam of light from a high energy gas laser is mechanically chopped into pulses before focusing onto the work roll surface. The high energy causes local melting of the roll, which, with gas jet assistance, results in the formation of a discrete crater. The roll is rotated and the laser beam moved axially along the roll in a manner analogous to conventional turning. So already we have discussed that in turning, what we do usually we rotate the workpiece in the headstock. In the similar way, the roll is rotated and the laser beam moved axially. Okay, here the roll is rotated and the laser beam moved axially along the roll. Okay, right. The depth and size of the crater can be controlled by the energy and dwell time of the beam. So here two parameters. One is energy and the other one is dwell time. Dwell means idle time. Okay. So the depth of size of the crater can be controlled by the energy and dwell time of the beam. Right. During 1994, Simao and co-workers concluded that LBT can produce regular patterns due to the periodic nature of the process. Okay. See here, laser beam texturing, LBT, nothing but laser beam texturing. Already we have discussed that. Okay. So here Simao and co-workers conducted the laser beam texturing can produce regular patterns due to the periodic nature of the process. Now let us see from this figure. Okay, here figure 5 shows typical examples of textured surfaces that are widely used in mold making, bearings and printer roll manufacturing respectively as described by Tanshoff and Sturmer. Okay, right here three ranges are there: random, rectangle, doses. Okay, so this is for mold making, random, and rectangle for bearing surfaces, doses for printer roller. Okay, so here structuring of surfaces with PMND laser radiation. Okay, this is given by Tomshoff and Sturman in 1995. Okay, right. Second one, dressing of grinding wheels. Lasers can create well-defined grooves on the grinding wheels due to the evaporation and damage of the composite wheel material. Okay, lasers can create well-defined grooves on the grinding wheels due to the evaporation and damage of the composite wheel material. Suitable selection of the dressing feed will result in the dressing of the whole wheel surface, thus changing its topography. Okay, suitable selection of the dressing feed will result in the dressing of the whole wheel surface, thus changing its topography. Laser dressing produces micro-cutting edges due to the formation of micro-craters on the worn-out grains. When these craters are formed in the bond, the grits are loosened and subsequently removed due to an insufficient volume of bond surrounding the grain. So here what is happening? Craters are formed in the bond, okay, and the grits are loosened and subsequently removed due to an insufficient volume of bond surrounding the grain. Okay, so there must be a sufficient volume of bond surrounding the grain is very much required. Okay, further, multiple cracks that are induced thermally during laser dressing help to remove the resolidified layer during grinding, which then exposes new cutting edges. Okay, so here multiple cracks, okay, that are induced thermally during laser dressing help to remove the resolidified layer during grinding, which then exposes new cutting edges. It is also possible to refresh the wheel by evaporating only the metal chips clogged on the wheel by focusing the laser beam suitably. However, selection and control of the laser beam should be carefully considered as mentioned by Ramesh et al. During 1989. Okay, it seems is an Indian author who has made these things for the laser beam machining parameters. Laser milling employing pulsed carbon dioxide laser has been investigated by Hu and Copley during 1990 in graphite as a model material. Okay, so this is about milling. Laser milling employing pulsed carbon dioxide laser has been investigated by Hu and Copley during 1990 in graphite, okay, as a model material. In this process, the material is removed by scanning the focused beam across the surface of the workpiece, leaving behind a series of narrow parallel overlapping grooves. Okay, series of narrow parallel and overlapping grooves. Okay, right. In order to remove layers bounded at the edges by upright walls perpendicular to the layer plane, the laser beam is tilted with respect to the layer plane. So here layer plane is an important element here. In order to remove layers bounded at the edges by upright walls perpendicular to the layer plane, the laser beam is tilted with respect to the layer plane. Okay, workpiece tilting depends on the incident power, beam speed, groove direction, and optical absorption coefficient of the material. Okay, so here workpiece tilting depending on incident power, beam speed, groove direction, and optical absorption coefficient of the material. Okay, next, Todd and Copley during 1997 developed a prototype laser processing system for shaping advanced ceramic materials. Okay, so Todd and Copley researched on advanced ceramic materials to develop a prototype laser processing system. Okay, this prototype is fully automated 5-axis closed loop control laser shaping system that accurately and cost effectively produces complex shapes in the advanced ceramic materials. Okay, right. Fine cutting and drilling. Next, Tabata et al. During 1996 reported that CW carbon dioxide layers are widely used for fine cutting of steel plates in the automotive, electric, and electronic industries, office equipment, household appliances, industrial machine parts, construction equipment parts, and construction materials. Okay, so here the laser is carbon tungsten carbon dioxide lasers. CW means carbon tungsten. Okay, right. In fine cutting, the thickness of the steel plate varies from 0.5 to 16 millimeters, allowing a cutting speed to vary from 6 to 1 meters per minute respectively. Okay, so here speed range is 6 to 1 meters per minute, and the thickness of the steel plate from 0.5 to 16 millimeters. Right, as depicted in figure 6, the achieved fine cuts were of narrow width and the cutting surface was clean and smooth. Okay, they also added that high power NDR lasers with high beam quality can be used for steel plate cutting in place of carbon dioxide lasers. See, this is for office equipment. Okay, this is for automobile parts and construction equipment by carbon dioxide laser cutting. Okay, right. The ND-AG lasers can also machine non-ferrous metals such as copper, brass, and aluminum alloys more efficiently than CO2 laser. Okay, since ND-AG is less reflective to such metals. Okay, so when we deal the metals like copper, brass, and aluminum, the ND-AG lasers are better when compared to carbon dioxide laser. Right. Plates of thickness from zero point 0.2 to 2 millimeters are finely cut with the output of 200 watts. So for 200 watts, what kind of thickness is suitable? 0.2 to 2 millimeters. Okay, right. A cutting speed of 5 meters per second for 1 thick plate has been also reported. Okay, the slit width and surface cleanliness are almost similar to carbon dioxide laser processing. Okay, so here we are comparing carbon dioxide laser processing with NDR lasers. Okay, right. During 1995, Kao and Huang invented a new technique for micro size laser machining, that is far below 0.07 millimeters, with varying curved wall surfaces, diamond wire drying dies using CW NDR laser. So here CW means carbon tungsten. Okay. Repetition frequency, laser power, and feed step of the laser head along the z-axis are the most critical parameters. Are those repetition frequency, laser power, and feed step of the laser head. Okay, right. Micro hole drilling in a single pulse using a pulse slab ND laser has been reported by Rohde and Verboen during 1995. Accordingly, holes with diameters of 35 microns in a steel plate of 1.2 and diameters of 6 microns in zero point zero 0.03 millimeter steel foil have been obtained. Okay, see this figure give the information about the 35 microns hole in 1:2 millimeters. Here this is 6 microns in 0.03 millimeters. So this is about fine drilling of holes in steel. Okay, right. This is comes under micro hole drilling. Next, the rectangular spot slab laser beam can also create a slit using a single pulse. Industrial applications for food industries are sieves with slits of 0.06 mm by 2 millimeters in a stainless steel of zero point 0.5 thickness at a rate of 100 slits per second. So all this numerical information is very much important to study and to research about the laser beam machining and the quality of the holes or machining process. Okay, right. Several pulses are used to create a hole percussion drilling mode. A 60 microns diameter hole has been obtained in 100 manganese chromium vanadium steel plate of 4 thickness with an aspect ratio of 65 to 1 using 4 to 5 pulses. Okay, so here this is single pulse, this is about 4 to 5 pulses. Okay, so in single pulse we are considering rectangular spot slab laser beam. Okay, and these are the details about the slits and thickness. Okay, so when we use 4 to 5 pulses, here we are using material 100 manganese chromium vanadium steel plate of 4 thickness and diameter is 60 microns. Okay, so these details will give and will lead for the further research on these parameters. Right, micro blind holes of 30 microns diameter with a maximum aspect ratio 12 is to 1 to 800 microns with aspect ratio 4 is to 1 have also been reported by Roth and Verboen during 1995. It is accordingly recommended to adjust the pulse duration and frequency to evacuate the molten material from the path of the laser beam. Okay, the trepan technique drills holes of diameters larger than the laser beam diameter and offers smaller conicity and higher repeatability of the hole diameter. Using such a method, holes inclined to the surface into fuel injection nozzles have become possible. Micro-cutting of 1 thick steel plate leaving a kerf of 85 microns at the entrance side and 60 microns at the exit side and leaving a taper of 1.25% have been reported. Okay, what is the method here? Trepan technique. Okay, next. Ricciardi et al. During 1996 developed an excimer laser based technique for marking computer keyboards with high speed and flexibility of the production line that avoids the use of toxic solutions in the marking process. So here marking of keyboards, okay, in the computer hardware units, marking of computer keyboard is an important element. Okay, so laser marking does not involve the introduction of any foreign materials or exert any mechanical stresses on the workpiece. Okay, so this is about marking of computer keyboard. The practical advantages of excimer lasers in marking processes are due to the short laser wavelength and pulse duration. Okay, so here wavelength is shorter and pulse duration is also less. Okay, high photon energy induces photochemical reactions in the material resulting in a color change with negligible side effects. Okay, high photon energy induces photochemical reactions in the material, resulting in a color change with negligible side effects. The laser marking cell is able to meet the requirements with the nominal throughput of one keyboard every 15 seconds. Okay, see how less it is. Okay, right. Trimming of electronic components, lasers of high power density, small spot size, and short pulse length are useful devices for modification of electronic components, often by selective evaporation. By proper monitoring, the device can be trimmed or adjusted by the required amount. Trimming of resistors composed of chromium silicon oxide deposited on the surface of a silicon chip has been achieved using an argonian laser operated at a power density of 0.8 megawatts per square centimeters with a pulse width of less than 10 microseconds. Okay, so this is about the power density, this is about the pulse width. Okay, right. Next, controlled fracturing. Laser energy can also be used to fracture or break in a controlled fashion delicate items such as electronic circuits or components. The absorption of the beam focused on a small area of the surface creates thermal gradients which in turn lead to formation of mechanical stresses that are sufficient to cause shearing of the material over a region so small that the fracture does not propagate in an uncontrolled manner. Using such a technique, high alumina ceramic 0.46 millimeters thick has been fractured in this way with 100 watts CWCO2N2He laser. Okay, so tungsten carbide, carbon dioxide, N2, helium. Okay, right. Dynamic balancing of gyro components. Laser trimming can achieve highly accurate balancing with material removal at a rate of milligrams per pulse. Shallow holes are produced. Okay, so with laser trimming, we can make shallow holes. The dynamic balancing is simplified by utilization of a signal from the points of the imbalance to trigger the laser pulse. Okay, so this is about the dynamic balancing of gyro components. Next one, scribing. Brittle materials like silicon, glass, and ceramic may be effectively separated or shaped by laser scribing. With this technique, material is removed by laser along a specific path on the surface of the workpiece. When the material is sufficiently stressed, a fracture occurs along the scribed path. Okay, so this is about the scribed. Silicon transistor wafers have been successfully scribed with a repetitively Q-switched ND laser of peak power 300 watts, pulsed at a rate of 400 pulses per second and a duration 300 nanoseconds. The rate of scribing reported by Megov during 1988 is 1.5 meters per minute. Okay. Next, last one, micro machining. Okay, Tonshoff et al. During 1993 investigated the application of excimer laser radiation in multi-axis CNC micromachining unit with modular design. The unit is used to generate microstructures in ceramic and polymer surfaces. Using such an arrangement, it was possible to produce micromechanical parts of these materials in the fiber reinforced plastics. Okay, laser assisted EDM. Okay, Allen and Huang during 1997 developed a novel combination of machining process to fabricate small holes. So before the micro EDM of holes, copper vapor laser radiation was used to obtain an array of small holes first. These holes were then finished by micro EDM. So first holes will be making. So next the holes will be finished by micro EDM. Their method showed that the machining speed of micro EDM had been increased and electrode tool wear was markedly reduced while the surface quality remained unchanged. So these are the references. So with this, I would like to conclude. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.